Welcome back, guys. It seems I've confused myself with all of my different colors, and I thought that there was something missing, but there isn't actually. Right, let's have a look at our parabola. There's our parabola. The line x is equal to -1 is the axis of symmetry of the parabola, and this is the line y is equal to 2, which means that the y-intercept of the parabola, now please try not to get as confused as I was. This is the y-axis. The y-intercept of the parabola is at 0, 2. Now, by symmetry, I can say to get from -1 on the x-axis, that's -1, to the y-axis, I have got to jump 1 unit. So, similarly, I can then say that the coordinate of A will be -2 and 2, right? So the y values at A and at the y-intercept are exactly the same, and from symmetry, to get from -1 to 0, I jump 1, so I've got to jump 1 to the other side, and the coordinate of A is therefore -2 and 2, so that's only 1 mark, so I should have known that that can't be too hard. Right, so let's put that information on here for us. I'm going to say A is -2 and 2. And what I'm just quickly going to do is I'm going to highlight the y-axis and the x-axis, because the fact that all of these lines are solid is what's making this all very confusing. Now, if I have a look at my hyperbola, and the next question asks me to find the equation of the hyperbola, I can actually see that my hyperbola is one of this sort. It's in the third quadrant, and it's in the second quadrant rather, and in the fourth quadrant, which means it hasn't been translated up or down, it hasn't been translated left or right. That was difficult to see though with all of these lines. So my hyperbola is actually in the form y is equal to a over x. So y is equal to a over x. Well, guys, that's easy, because now I know that the x and the y-axis are my asymptotes. So no other value for p and q other than 0. So all I need to do now is substitute the 1 point that appears on my parabola and my hyperbola into y is equal to a over x. Remember, x in the place of x, y in the place of y. So I'm going to say 2 is equal to a over -2. So a is -4, and that makes sense. It's consistent with the fact that my parabola is in the second and in the fourth quadrant. Remember, if a is positive, my parabola will be in the first and in the third quadrant. So I've said that a is -4, but let me just write down the equation of g. I can then say g of x is equal to -4 over x. Plain and simple, nothing too hectic about that. Right, now the next question that we are asked is to determine the equation of our parabola. Now let's just clear up a little bit here so we can see what's going on. Now, the first thing that we need to take into consideration is the fact that the axis of symmetry of my parabola is at x is equal to -1. So if I put into the standard formula, I'm going to say y, I think that color might be a little bit too light. Let's take a better one. I'm going to say y is equal to a. Now, my parabola has moved from the y-axis 1 unit to the left. So this is going to be x plus 1, everything squared. And because it is on the x-axis, there is no q for us to worry about. Guys, this is something that often confuses people. If you are translating a point to the left. Then x minus will mean that the point moves to the left. However, if it's a function, it's the opposite way around for the x's, so don't forget about that. Right, now the only thing that I need to find still on my parabola is the value of little a, and I'm going to do that by substituting my point a, which I found in the first step. So I'm going to say 2 is equal to a. Right, and I'm going to substitute in x is equal to minus 2 plus 1, and everything's squared. And then negative 2 plus 1 is negative 1, but negative 1 squared again is 1. So a is equal to 2. So the equation of my parabola, I think it was called f, is f of x is equal to 2x plus 1 squared. And if you want to write the q, you can write plus 0, because the question did in fact, oh, I haven't actually gotten to that question yet, so there we go. The question said find the equation of the parabola in the form y is a x minus p squared plus q. So if we're going to put it in that form, it's y is equal to a, which is 2, and you could, if you wanted to, say x minus 1 squared, but I don't think they will be too picky about that. And because it's not translated up and down, q is 0, and I wouldn't expect them to want that from you as well. Now, guys, just quickly, I want to talk to you in general about translations with our graphs. It's very important that you guys see that everything is interrelated. Y is equal to a x minus p squared plus q is our general equation for a parabola. Right. So what does a do, what does p do, and what does q do? A controls the steepness of the graph. So if a is positive, your graph will look like that, a happy face. If a is negative, your graph will have an unhappy face. Also, the bigger the value of a, the quicker your graph will go either upwards or downwards. Then the p inside the bracket there moves the graph left or right. So if I have, let's say, x plus 2, it means from the standard position, your graph has moved 2 units to the left. If I have x minus 3, it means from the standard position, your graph has moved 3 units to the right. The value for q controls the up and down, and that works exactly like we think it should. Plus 3 moves the graph up 3 units, minus 3 will move the graph down 3 units. Now, if you guys compare those things to your hyperbola, let's say y is equal to a x minus p squared, plus q. Again, the value of a determines where your hyperbola is going to be mostly. A positive value of a means mostly in quadrant 1 and 3, negative 2 and 4. Also controls the steepness of the graph, exactly the same as for the parabola. Then the p-value controls the translation left and right. So if I have in the denominator x minus 2, it means from the standard position, the graph has moved 2 units to the right, exactly the same as for the parabola. Just bear in mind as well with the hyperbola that in the denominator, you cannot have a 0, and that is why I have my asymptotes. Then, guys, finally, if we have a look at the general equation of an exponential graph, it's exactly the same. I'm going to write it y is equal to a b to the power x minus p plus q. Again, the q moves the value up and moves the graph in its entirety up and down. The p moves the graph left and right, and the a controls the steepness or which way around your graph what your graph is going to look like, which way around in terms of like that or like that. Okay, now if we relate this even to our trig graphs, guys, even in the case of our trig graphs, these translations are exactly the same. So if I say y is equal to a sine x minus p plus q. Again, the value for a controls the steepness of the graph. P moves the graph left and right. And again, negative 30 degrees means 30 degrees to the right. Positive means 30 degrees to the left. And the q moves the graph up and down. So very important that when we're dealing with our functions that we realize that parabola isn't one thing and hyperbola isn't something completely different. Okay, now there were still some questions left on this, sorry guys, let's just find it quickly. We're on question 7. I wasn't quite finished with the graph question, so let's quickly finish up the questions. Right. Oh, okay, well, I can't seem to open it now. It doesn't matter. I'm going to just give the questions to you guys verbally. Oh, there we go. So the next one and the next one and the next one. Right. The next question, 7.4, is determine the equation f minus 1 in the form y equals. So what they want from us is the inverse of our graph f. Now let's go back to our graph f. Alternatively, we could see it as what would the equation of our graph f be if it was reflected in the line y is equal to x. So let's quickly write out our equation. It was y is equal to 2x plus 1 squared, if I remember correctly. Right. Now, what I'm going to do is I'm just quickly going to multiply this out. I'm going to get 2x squared plus 4x plus 2. Okay, 2x squared plus 4x plus 2. Now, guys, whenever we reflect in the line y is equal to x, and this again is true for all of our graphs. Let's put the line y is equal to x in here. Whenever we reflect in the line y is equal to x, what happens is that our x values and our y values switch around. So y becomes x and x becomes y. So let's have a look at what that will give us. I'm going to say x is equal to 2 times y plus 1 everything squared. So that is the equation of the graph once we've reflected it in the form y, in the line y is equal to x. And irrespective of what sort of a function you're dealing with, what you do is you're going to switch the x and the y values around, and usually they would then require us to write our answer in the form y equals. Okay, guys, so that's all from us at Learn Extra for today. We've managed to have a look at some sequences and series, at some functions, at a little bit of calculus. And remember, up next we have got science. After science we have got life science, and thereafter it's time for the maths lit team. So from me and the Learn Extra team, good luck. Good luck for paper 1, good luck for paper 2, and we'll see you guys again soon.